Good evening, dear friends. In the series of learning aerodynamics, we are discussing on the climbing flight. So, in this video or in this lesson, let us discuss how the speed stability affects the performance of the or performance of the rate of climb. Because speed stability generally is very important in the steady level flight. So, because even though we are discussing on the climbing flight, this also comes under the steady level flight conditions. So whenever we just go with the steady level flight, then speed stability, okay, very important, because speed stability generally exists when the power available equal to power required. So that is what we are seeing in the, that means thrust power required, this velocity, this graph. So in this graph, okay, we can see that, okay, how the power available and power required curves are drawn. And in this we all know, okay, suppose how we can just get the speed stability, because only at this point, only this particular point, we just have the speed stability. So if the aircraft is flying with some velocity, then if it is below the speed stability, then if at all we want to fly with fly in the steady level flight, then we need to go back. So that is the idea. So we are flying with some velocity that is less than the speed stability point. Then just by increasing, or okay, by changing the power available and power required conditions, we can go back to the speed stability. It means, suppose if you are here, so if we are here particular at this point, at this particular point, then what happened, we say that, okay, our power available exceeds the power required. So power available exceeds the power required. So in that condition, what happened, we can go back, that means we can go forward to the this point, so that we can achieve the speed stability. Because when we are at this point, so that means the aircraft is under climbing condition. We are, when we are at this point, particularly at this line, we are in, the aircraft is under the climbing conditions. So once the climbing is done, then we have to go back this point. So how will you go back? That means only when the this, by increasing the speed. So that time, okay, we can just go back and we can come to this point. So by that way we are achieving the speed stability. So whenever we are in this climbing condition, what happens, power available is higher than the power required. So that point we have to understand. So power available always, okay, should be higher than the power required. Then only we can go for climbing, that means climbing flight is possible. So that is one thing. So if just for example, suppose this is the condition, that means our minimum drag is okay, exist. So minimum drag condition exists. Then going back from this point to this point is very easier. For suppose if you say minimum power conditions, we all know minimum power conditions is okay, that velocity slightly lower than the minimum drag velocity, because minimum power velocity, we know that is nothing but 0.76 times minimum drag velocity. So from going back or going forward from this point to this point is very difficult. Then going back from here to here, because this is within the range, so that whenever, okay, we are in the climbing, so once it is done, then we can go back here, so go back to the speed stability point. So if you are in the minimum power conditions, so that is very much lower than the minimum drag. So that time, okay, going back from here to here, it is somewhat challenging. So especially at this point, what happened? So because of that reason only, we say that speed stability problem. That means the problem of speed stability arises when we are in the minimum power conditions. So suppose if you want to still if you want to go with minimum power conditions, and we all know that minimum power conditions, whenever we are choosing to fly with the minimum power conditions, that time only we are achieving the maximum rate of climb. So that also we know. So then so if you want to fly with the maximum rate of climb conditions, so even though there is a problem of speed stability arises, but still okay, we can go with the minimum power conditions. That is by using the anti-throttle control. By using the anti-throttle control, so what we are achieving, indirectly we are achieving the artificial speed stability. So because we cannot go up to this point, maybe okay, we can create a situation how okay, some similar to the speed stability conditions. So that is what we are achieving with the help of anti-throttle. So that is okay, that is only for when we are flying with the minimum power conditions. I hope okay, why do we need to okay go with the anti-throttle control to have the artificial speed stability, and because of that okay, how do we okay overcome certain issues. So that is clear from this discussion. And also when speed stability exists, that is also we can understand okay from this curve. And this and all required, why? Because we are okay, we are flying in the steady level flight. That means we are discussing in the steady level flight.